Hi everyone, this is Tarun Khandagare working as a senior software engineer in Visa. Today we are going to discuss very important problem which recently asked from me in the bar raiser round of Amazon. It means that whether this tree is a mirror of itself around the center. So if I consider this example and draw a line at the center point from the root, so we can say that the left subtree is mirror at the right end, or we can say that if we want to mirror it, the left subtree towards the right subtree. Okay, so how we can mirror it? Okay, let's check this. These two on the left side come at the right side. Okay, these three at the left end come at the right side of the tree. Okay, these four in the left subtree come at the right subtree at the left side. Okay, so this came here. So as you can see that by seeing this we can say that if any node is at the left end, that node can came at the right end. Okay, and the node at the right side, we can say that it can came at the left end. So this is the definition of mirror or symmetric. By seeing this tree, we can say that it is a mirror of the tree and it is a mirror around the center, so we can say that it is a symmetric tree. Okay, let's take another example. By seeing this example, if I draw a center line around the root, from the root, okay, so by seeing this structure or by seeing this binary tree, we can say that it is a mirror or symmetric tree, but it is not. Let me show you the second example of it. Okay, so this is the tree. If I draw a center line from the root, by seeing this tree or seeing this binary tree, we can say that this is a symmetric tree, but actually this is not. Let me show you why this is not a symmetric tree. If I try to mirror it, okay, if I try to mirror it, the left part to the right side of it, okay, so this is the left part, this is our right part, and we draw the line from the root and toward the center point. Okay, so if I try to replicate this left node toward the right node, it's came correct. But if I try to replicate this 3 node, 3 is at the right side of it. Okay, so and this is also a right side. By seeing this, we can say that if it is a symmetric when this 3 came here, but it is not here, so we can say that this is not a symmetric tree. Hope you understand. Okay, or we can say that here left comes towards right or right comes toward left. Okay, that condition is true, then only we can say that this is a symmetric tree. Let's try to build the logic to detect whether the tree is symmetric or not. So before detecting the logic whether the tree is symmetric or not, we want to know that what is mirror. So mirror is what? Left come at the right end, right come at the left end. When these both condition will become true, then only we can say that left subtree is a mirror of right subtree or right subtree is a mirror of left subtree. And if both conditions are true, and we can say that the mirror is around the center point or around the root point, we can make sure that it is a symmetric tree. So let's try to build the logic for it. So can I say this? If I ignore the root value, root left subtree is a mirror of root right subtree, okay, or root right subtree is a mirror of root left subtree, okay. So this both condition you understand, okay. If I do in order traversal, okay, on the left subtree and on the right subtree, so how the in order traversal looks like? We need to pass the root, we need to pass the left, we need to pass the right, or at the right side also we need to pass the root, we need to pass the right, and we need to pass the left, okay. So suppose if I am doing in order traversal, how in order traversal works? We need to ignore this root value because we are starting our in order traversal, okay, from left node or left subtree, or in order traversal from the right subtree, okay. Or what we can say, we are comparing this two value and this two value, okay. So as you can see there, okay, left is compared by right, right is compared by left. By writing this condition, we will make sure that when this 3 is compared to this 3 and this 4 is compared by this 4, okay. Because let me explain how we are going with the flow or how we are traversing with the flow, okay. So if I came at 3, okay, so we are comparing the right subtree 3 because we mentioned left is compared by right. So this is our left node, this is our right node. We are comparing two and checking whether both are equal or not, okay. We checked right subtree, we checked left subtree. This both also we checked, and we checked whether that three nodes are matching or not. If it is matching, that means that this whole left subtree, this whole right subtree, the values are in mirror position, or we can say that it is in symmetric state. Let's take the second example and try to dry run on that, okay. So root is ignored, okay. We need to compare the left subtree and the right subtree. So if we are doing in order traversal and if we are comparing root left comma right, root right comma left, okay. So if I come in here, okay, so these values we are comparing in the first round of traversal. Then this statement, this in order traversal, okay, we are doing two in order traversal, okay. This in order traversal will go in the left side, it will go in the left side and it will check no values found, okay. And this is also, it will go on the right side, okay, and see some values are there. So you can say that here we didn't got the value, here we got the value, so these are unequal, these are unequal, or we can say that this is asymmetric tree, okay, non-symmetric tree. Same when we are going this way, okay, when we are going right side and we got the value 3, but we are going when we are going in the left side are comparing these two values, we can say that this is a non-symmetric tree. So that is the reason we are saying it is a non-symmetric tree, because value on the right side not present in the right subtree, okay, and value of the right subtree is not present at the left subtree, okay. So hopefully you will got the logic how we are going to build this system and how we are going to traverse it using in-order traversal. We are calling two functions, and based on that we are comparing the left subtree and right subtree and try to check whether both subtree are mirror of each other. If it is a mirror of each other, then we can say that it is a symmetric tree. So as you can see here, we write the base condition. When root is null, that's mean whole tree is not present. Okay, so that time we directly say that tree is asymmetric, or we can say that this tree, this binary tree is symmetric, not symmetric tree. So this is the base condition I wrote. If I see that, what does it mean? It means that the binary tree doesn't contain a value. So that time we directly say that this tree is not a symmetric tree. And then after that, if binary tree is present and this contains this type of values, this values binary tree contains, that time I trigger my util function and trying to do a in-order traversal on the value left, on the subtree of left and on the subtree of right. This is the subtree of left, this is the subtree of right, and we are checking this left subtree is a mirror of right subtree, or this right subtree is a mirror of left subtree around the center. Okay, so let's consider this example. 2 3 4 is a subtree, left subtree of a binary tree, and 2 3 4 2 4 3 is the right subtree of a binary tree. So if I try to compare this tree and decide this whole tree is symmetric or not, so we are calling this thing and this thing, and we are passing argument. As I say, we are comparing the right side toward the left side and the left side to the right side. By seeing this, we suppose this values is equal to this value and this value is equal to this value, and this 4 at the right end is equal to the 4 at the left end of subtree right. Okay, same tree, same thing we are comparing here. What we are comparing, L1 value equal to L2 value. If it is not equal, that means that this condition is happening. 2 left node compare by 2 right node, so one is null, the second one is not null. That is the condition. That time we have to say this tree is non-symmetric tree, okay, or not a symmetric tree. Okay, hopefully you got this. Or in this condition, when 2 3 4 are there and 2 4 3 are there, this values is always equal and this will return true. Okay, so hopefully you got our logic, how we are going to compare the values of the right subtree to the left subtree, and we are going to try to match whether the left subtree and the right subtree is mirror of each other. If that is the case, or that condition true, we can say that it is a symmetric tree. So let me run the code and check that code is performing correctly or not. So let me run. So sample test case is passed. As you can see here, our output is true and expected is also true. In second case also the same possibilities are there and we are getting the right output. Let me submit and try to run for all the test cases, and let's see how this code works. So it is expected. So it is accepted. Our code works fine. Hopefully you got the logic, you got the solution, how we are going to do that. So the complexity of the code is big O of n, and the space complexity is also big O of n. So hopefully you like the video. See you next time.